Today we will talk about the matrices to use when dealing with rotation. For anti-clockwise rotation, we use the following matrix for any degree. Note that it says anti-clockwise. That would be going the opposite way of a clock. There is a different matrix we use when it is a clockwise rotation. So there are only two matrices to memorize. For anti-clockwise, it is the cosine of theta, which is simply just a degree. So cosine of the degree, negative times the sine of the degree, sine of the degree, and cosine of the degree. For example, substituting 90 degrees into this, cosine of 90 degrees is just 0. Sine of 0 times negative 1 gives us negative 1. The sine of 90 degrees is 1, and the cosine of 90 degrees is again 0. So we use this 2 by 2 matrix when rotating 90 degrees anti-clockwise. Example 1. A parallelogram is defined by the points A 2, 1, B 3, 3, C 6, 3, and D 5, 1. Calculate the points defining the image when the parallelogram ABCD undergoes an anti-clockwise rotation about the origin through the angle of 1, 90 degrees, 2, 180 degrees, 3, 270 degrees. Part B, draw a graph to show the parallelogram ABCD and its images. So I will be showing 3 examples, 3 rotations, and then how they all 4 of them will look on the graph, including the original image. Example 1. Substituting into the formula, I get 0, negative 1, 1, 0 to multiply ABCD by. In doing so, I'm going to do A for the top and the bottom, and then move to B, and then C, and then D, etc. So for point A, 0 times 2 minus 1 times 1, 1 times 2 plus 0 times 1. That's for point A. Point B is 0 times 3 times negative 1 times 3, and 1 times 3 times 0 times 3, point B. Point C gives 0 times 6 times negative 1 times 3, and 1 times 6 and 0 times 3. Point D gives 0 times 5, negative 1 times 1, 1 times 5 plus 0 times 1. Adding everything together, 0 minus 1 is negative 1, 0 minus 3 is negative 3, 0 minus 3 is negative 3, 0 minus 1 is negative 1. 2 plus 0 is 2, 3 plus 0 is 3, 6 plus 0 is 6, and 5 plus 0 is 5. Hence, the points after the 90-degree anti-clockwise rotation is negative 1, 2, negative 3, 3, negative 3, 6, and negative 1, 5. Part 2 says to rotate it 180 degrees. Substituting into cosine of 180 degrees is negative 1. Sine of 180 degrees is 0. Negative 1 times 0 is just 0. 0, negative 1. And again, I perform my matrix multiplication. Negative 1 times 2, 0 times 1. 0 times 2, negative 1 times 1. Negative 1 times 3 plus 0 times 3. 0 times 3 minus negative 1 times 3. Negative 1 times 6 plus 0 times 3. 0 times 6 minus negative 1 times 3. Negative 1 times 5 plus 0 times 1. 0 times 5 minus 1 times 1. Then I add everything together and get negative 2, negative 1, negative 3, negative 3, negative 6, negative 3, negative 5, negative 1, and I plot the points. Part 3 said to rotate it 270 degrees anti-clockwise. Substituting, the cosine of 270 degrees is 0. Sine of 270 degrees is -1 times -1 gives me a +1. Sine of 270 degrees is -1 and cosine of 270 degrees is 0. Again, I perform my matrix multiplication across and down, across and down, across and down, across and down, across, down, across, down, across, down, across, down, for each point. I get my ordered pairs: 1, -2, 3, -3, 3, -6, 1, -5. Then for part B, I'm asked to graph my points. This was the original image, A, B, C, D. After a 90-degree rotation, anti-clockwise, this was A1, B1, C1, D1. The second transformation here and the third transformation here, we can see that it rotated 90 degrees, 180 degrees, 270 degrees. On your own. Please complete the following. For clockwise rotation, there is a simple change made to the matrix. We change the sign of sine. Sine at the bottom becomes negative, and the sign at the top becomes positive. We substitute the degrees just like we did for anti-clockwise rotations. Try one. If I were to substitute 90 degrees into this formula, I get the following matrix: 0, 1, -1, 0. Example 2 can be found in your textbook on page 945 of 90-degree clockwise rotation, etc. Here is the on your own question for clockwise rotation. How did you feel about this video?